This session, this is the first keynote, session 1 of 24, The Art of Simplicity by Venkat Subramaniam, keynoting and kicking off our entire vJUG24 conference. The sponsor for this session is Google Cloud, one of our gold sponsors, so a big thank you to Google Cloud. And the participating GUG there is Melbourne JVM Group. It's a little bit about Google Cloud. Google Cloud Platform has a variety of cloud services from infrastructure as a service, big data, machine learning, and they also have a managed Kubernetes environment that you can easily run containers at scale, as well as manage an application platform called the App Engine. People are probably familiar with that from the years gone by. The Google App Engine allows developers to build modern web and mobile applications on a modern cloud platform. They also now support Java 8, so you can take your own framework there if you wanted to Spring Boot or whatever. And in addition, Google are actively meeting where developers are. So as I mentioned, Spring ecosystem, you can develop in Spring to produce a Spring Cloud GCP that provides an easy set of the Spring Boot starters, which people are maybe familiar with, to consume the Google Cloud Platform services, whether it's Cloud SQL or messaging with PubSub, or distributed tracing with Cloud Spring Sleuth using Stackdriver Trace as a backend. So if you wanted to take a sneak peek at that and let Google know your feedback, do check out those links. There are actually some nice tutorials in that first one particularly, and the Spring Cloud GCP shows you a whole bunch of the kind of starters that you can go from. Also, Zero Turnaround are the main sponsors of the virtual JUG, so big thank you to Zero Turnaround for providing the vJUG with all the support, the money, and the time that it needs to create things like the vJUG24 and other sessions and podcasts all throughout the year. So big thank you to Zero Turnaround as well, providing developer productivity tools and other tools that allow developers to develop at warp speed. The virtual JUG, if you wanted to join and connect on Slack, that's where we'll be asking all questions. So any discussion, any questions in the live session channel on Slack. All tweets can please tag vJUG24. That's our Twitter hashtag. And for this session and others, if you increase your video quality by clicking the cog at the bottom of your video, try and choose the highest bitrate as you can, so that, or highest resolution you can. That'll allow you to view any code or slides in the best possible quality. If you wanted to join Slack but didn't know how, on vjug24.com, there will be, just beneath the video, there is a Slack. There's a link that will allow you to join the Slack group. But that's enough from me. I want to jump straight over to Venkat, who's already screen sharing. There we go. So over to Venkat, who's going to start our first presentation of 24. Venkat, please, over to you.
All right. Well, thank you very much. It's a pleasure to be here. I'm going to talk about simplicity and complexity. So let's get started. Well, one of the things we deal with every single day at our work is we solve problems, and we end up with solving very complex things. But where do these complexities come from? How can we really benefit from dealing with these complexities? That's what I want to focus on in today's presentation. So one of the very complex things that we work with every single day, thankfully, is the human brain. So we humans are extremely complex. And of course, we are very creative. We can come up with solutions. How many times we sit down and ask the question, wow, how did you think of that? So creativity is one of our key strengths as human beings. But one of the things that also makes it really hard for us, unfortunately, is the things that get complex and tangled up. We get really confused. We get emotional. We can't think clearly. How many times have you been struggling with the problem for a few hours? You walk away for a few minutes, and then on the way out, you suddenly think of the solution. It's pretty fascinating how we really end with complexity, and then we have to really work hard to deal with it. Well, among my children, we often have the discussions about Schrodinger's cat. Schrodinger did an experiment where he had a cat in a box which had a vial, and of course, at any given time, you can't tell whether the cat is dead or alive. Well, life is somewhat like that. Oftentimes, we deal with things. We'll circle back to this a little later. So the question really is, why do we really deal with this? Well, life is really simple, but we insist on making it complicated, says Confucius. Why do we want to make things really complex? Well, I think I have a reason for it. The very first reason I think is it really feels good. When we make things complex, it feels good because we feel like we're doing something really important. It is a good way to impress our colleagues and friends and others as well. Maybe we had an intern and the intern goes back to school and says, well, the folks I work with are amazing. I understood nothing of what they do. Well, we kind of feel good when we create complexity, unfortunately. Well, complexity also leads to job security, isn't it? When it comes time to lay off, they would say, whatever you do, don't touch Joe, because no one understands what Joe is doing. So complexity can also help us in job security. But complexity also leads to jobs that we eventually hate holding. It's not a very fun situation to be in when we are constantly faced with issues and we can't really solve problems so easily. So what can we do about it? Well, Einstein said, any intelligent fool can make things bigger, more complex, and more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. I want to underline the word courage here as well, because a lot of times when we present a solution which is really simple, we might get ridiculed by the team. We feel a little threatened. Well, gosh, that's too simple. It's not really useful then. It's too simple then. It doesn't really solve the problem maybe. Maybe it's a little too simple. Let's come back and revisit this. So it takes courage to really stand up and say, no, I really want to present this solution. It is simple. It solves the problem we have at hand. It's easy to manage. And that courage is actually really, really important for us to be able to bring about simple solutions. So if simple is really important, why can't we all just make things simple? Well, it turns out, while every one of us will agree that we have to make things really simple, very few of us really have an idea what simple really means, especially in a given context. It really becomes hard. As a consultant, I work with a lot of different teams, and I would say that this is complex, and the team would ask me, why do you think this is complex? We think this is simple. So if simple were sitting next to you in the bus or a train, would you even be able to recognize simple? So that's what I want to talk about, is what is really simplicity and how could we really move towards it? But as it turns out, it's really, really hard to find and identify simplicity. So I'm going to head in the opposite direction just for a little bit. What about talking about things that are not simple? Well, I think we can easily do that. If we can point to a certain number of things that are not really simple, maybe then we can say, hey, this is really not simple, avoid it. And maybe what's left is going to be rather much more simpler. Let's give it a try. So what is not simple? Well, the very first thing I want to start out is simple is not clever. Well, how many times we have come up with clever solutions? Well, that means how many times have we really sat down to write code, isn't it? We programmers take pride in coming up with clever solutions. We do. And there's nothing wrong in being proud about our solutions. But unfortunately, clever solutions come back to haunt us in the long run. It reminds me of an experience where a client called me up and said they have an issue that they need to solve, and I looked at it. It would have taken me 10 minutes to solve it. Oh boy, why solve this problem when you can solve a meta problem? I want to solve any similar patterns of problem from ever occurring. So I spent an hour solving it. And when I finished it, it felt so good. I had an out-of-body experience. Venkat got up and hugged me in the back and said, you're awesome. This is great, because I'd solved a meta problem instead of solving a problem itself. Well, a few weeks went by, and I got a call from the client saying something terribly has happened in production. I said, oh, I know I can handle it. Got this, I can handle this. And they said, oh, you can because you're good. It's like, no, I can handle this not because I'm good. I can handle this because I'm the one who caused the problem. Well, the clever solution I had put in place totally backfired. We all come up with clever solutions that others feel really hard to understand. Let's look at one quick example here. Well, here is enum from Java, public abstract class enum. E extends enum E. Wait a minute, enum, where E extends enum E. Well, that little noise you just heard, that's your brain throwing an exception. So this is an example of a fairly clever code. A lot of us would have difficulty understanding what this means. I'm sure some of the authors themselves have to stare at this for a while to figure out what it's doing after a while. So when I go to teams, often they ask me, how do they obfuscate their code? And I often tell them their programmers are naturally inclined to write self-obfuscated code. Why bother really using obfuscation tools? We tend to really write clever code, and clever code often obfuscates the code. It becomes really hard to understand and maintain it as time goes on. For example, I came across this piece of code, and I don't have a clue what X means. I don't have a knowledge of what X means in this context, but it took a value of X, and here is half of X. Well, and then, of course, you can see the rest of the code, and we can't tell we don't understand this. We have to really know what these things mean to look cool, isn't it? Well, that's quite a bit of mess that we deal with where we do all these transformations. And I don't know what this code is doing, but I got some good news for you. Whatever X was, whatever this code is doing, finally it returns X. Well, that's an example of, again, a very complex piece of code, and it takes a lot of time and effort to understand what this piece of code is actually doing. Well, you know, how somebody said object-oriented programming models are real world. Well, a developer kind of took it to heart. He was working on a flight simulator and created this piece of code. How do you deal with this? Somebody should have said, stop, don't go over there. Well, that becomes really hard to maintain. We deal with these kinds of things all the time, where the code is really something in front of us. It works, or at least it pretends to work, but how do we really know what the code is really doing? So the very first thing I would want to start with is a simple code is not clever. I would rather have a simple code that is clear than a code that tries to be really clever. The next thing I want to talk about here about simplicity, or the lack thereof, is simple is not necessarily familiar. Well, when we talk to programmers, when we are interacting, we often tend to associate the word simple with the word familiar, and we have to be very careful about it. Familiar is something that we have seen several times over. It is something we not necessarily familiar. Sometimes what is simple may be totally unfamiliar to us. But as human beings, when we look at something that's very unfamiliar, our brain immediately throws a little fit and says, oh my gosh, no, this got to be complex because I don't understand this stuff right away. Well, we got to ask the question, is it really complex that we are looking at, or is it really unfamiliarity that's really bothering us at this point? If I show you this symbol and ask you what it means, well, it depends on whether you know the language or not. And for the rest of us who don't know the language, we probably look at this and say, oh my gosh, that's really complex. But as it turns out, this actually says it's simple, in fact, uncomplicated, casual, and common. Well, but what is common and casual and complicated and very normal to a group of people may be really complex to somebody else because they lack the context, they lack the familiarity of things, and we have to really take the time to understand that. Let's take a look at a simple problem, but unfortunately, the solution may not really be that simple. So here is an example of a bunch of names. We don't even see what names are here in the list. It's hidden behind, but that's okay. But the problem says print comma separated, the names in uppercase of length 4. Hey, that should be really simple to do, isn't it? So let's go ahead and start with a for loop. We'll say string over here, and then we'll say name coming from the variable names, of course. And I want to start out by printing maybe just a name to begin with. That's not what the problem says, but that's a good start. It really wants names that are of length 4. Well, okay, we can say name.length is going to be equal to a size of 4. We could start with that. And then we can ask for it. Well, that's great, but it wants them in uppercase. So we can say 2 uppercase right here. Well, that's great so far, but it says that it should be comma separated. So we could add a little comma to that as well. But we know what it really means is they have to be on the same line. So we could remove the println to a print, of course. But then we notice there's a stupid comma in the very end. Anyone who has faced this problem before? Well, that's every single programmer who has walked this planet, isn't it? Well, it's very annoying. And the first time you ran into this, you probably sat down and said, this is not happening to me. Well, a very simple problem here. How do I get rid of that stupid comma in the end? Now we are sitting down to devise a complex set of solutions to do something extremely simple. Oh, darn it, string is not mutable. Maybe I can do an index off and strip out the last comma and the space. Oh, maybe I'll I'll put this in a string builder, or maybe I should use an index I equal to 0, I less than. Oh, darn it, that also becomes really complex because the value that is selected is not necessarily the last value. Well, try giving this problem in an interview and watch the person being interviewed suffer in front of you and run away screaming if you tell them this is how most of your code is. But it doesn't have to be really this complex. This is a very familiar for loop. Every single programmer understands for loop, especially in language like Java, but it's familiar, but I would argue this is a very complex solution, not a simple solution. Thankfully, there is a simpler solution we could actually use, but it's something a little bit unfamiliar to a lot of programmers coming into functional style of programming. So what we could do here is, we could start out by saying, first of all, we could say names.stream, where stream is a nice little internal iterator. We could filter out, given a name, I only want name.length is equal to 4. Well, that gives me all the names that are of length 4. We perform a nice little transformation of a string to uppercase. And then once we transform to uppercase, we can collect it, and then we can collect it joining. And then in this case, using a comma, that's what I want to do to join this. And joining is coming from the collectors utility class, which is really a beautiful helper class. So we could take the stream, we could filter out names that are of length 4, we can transform that to an uppercase, and then we can collect it joining with a comma in the end. So you can see how we don't have to deal with this. Solution is not complete yet. It's going to require a lot more effort to solve this using the imperative style, whereas this one is a single pass through. You read it from the top to the bottom, and the code begins to read like the problem statement. That becomes really, really, really easy to work with. And this is something to really consider. Well, a lot of times, very many programmers are getting just warmed up and getting used to the functional style of programming. It's rather unfamiliar to a lot of us. But once we get familiarized with it, we can then ask the question, is this simple or is this complex? And not before that. So don't confuse familiarity with simplicity. They are completely orthogonal to each other. Something that's familiar may actually be complex. Something that's unfamiliar may be complex or may be simple, but we haven't given it a chance yet to be evaluated because we are quite unfamiliar with it. And it turns out a lot of us are familiar with the imperative style of programming, but declarative style, which is really behind the functional style of programming, is a lot simpler in terms of removing the accidental complexity in code. So simple has fewer moving parts in it. Imperative style of programming often deal with enormous number of moving parts where we have to juggle through a lot of different things, and that becomes really hard to work with, whereas simple is really something has fewer moving parts in it. So we talked about simple is not clever, simple is not necessarily familiar. The third thing I want to talk about is simple is not over-engineered. We tend to do this quite often. We want to create software that is extensible. But the problem is most of us don't have a clue what extensibility really means in a certain context. And in order to achieve this unknown extensibility or perceived extensibility, we end up creating complexity into products. Ralph Johnson, one of the authors of the Design Patterns book, says it nicely. He says, we build hierarchies, we build interfaces, we build all these things around to promote that extensibility, but when the time really comes to extend, those very things that we set out to create extensible software really makes it hard for us to extend in the long run. So we have to really make sure what we are creating is extensible, but we have to understand what that extensibility really means. It reminds me of a situation where a programmer was building what we would call as a Rube Goldberg machine. Rube Goldberg is a guy who made his name creating cartoonic characters of very complex solutions for very simple problems. Well, at work, I saw this one day where a data was coming from a database transformed with 250 lines of code into XML and then sent to another method which was parsing that XML and then making a little transformation and putting the data back into the database. When I looked at this code and tried to figure out what the code was doing, I went to the developer and said, hey, this code is taking this data, transforming to XML, taking the XML again, transforming it to data, doing a little manipulation, and putting it back here. And the minute I said this, he said, isn't that cool? It's like, no, it's not cool. Why are we doing this? He said, because it's extensible. It's extensible for what? Oh, Venkat, you need to have a vision, he said. Vision for what? I don't understand what our purpose here is. Oh, no, you need to have a really broad vision. Now the data can come from anywhere, and the data can go anywhere. And so where does the data come from in our requirements? From right here in this database. Where does it go according to requirement? Right here into the same database. Then why are we talking about it can come from anywhere at this time? He said, no, you really need to have a vision. Now the data truly can come from anywhere. I never have to worry about what the data source is and where the destination is. While he was doing it, I fiddled with my phone. He said, excuse me, and he picked up his phone and said, hello. I said, hello, and he said, hey, is that you, Venkat? I said, like, yeah, that's me. Why are you calling me when you're in front of me? I said, you need to have a vision. I could be anywhere now talking to you. Why should I talk to you in person? I should always use a phone to talk to you, even if you're in front of me. Well, that's kind of silly, isn't it? Well, first of all, we have to understand what the real problem is and not end up over-engineering solutions for it. Well, we talked about something that's not clever, something that's not necessarily familiar, not necessarily over-engineered, but also sometimes programmers get excited about writing very concise code. I actually face this problem on projects where people go overboard to make the code really, really fewer in lines, and that actually hurts us. My goal is not to make the code short. The goal should be to make the code clearer. So don't confuse the simplicity versus conciseness versus terseness. Well, I say that a code is concise if it's fewer in lines and clear and transparent. A code that is terse is fewer in lines, but waiting ready to hurt you when you least expect. It's really hard to understand. It's got hidden things in it. Let's take a look at an example. I saw this on a project, and this is an example of terseness, and below this was a comment that said, God help me, I have no idea what these things mean. Giving a variable name that tells us what it stands for is very critical. Let's not make it terse. Similarly, here is an example of automated test in JUnit 4. And if you notice over here, or JUnit 3, even if you want to think about it, and this is a bit verbose. It calls a set price, it calls a max profit, wraps it around with a try and catch block for insertion. Oh, wow, we got to really make this more concise. But in the process, we actually make it terse by using this syntax. In my coding standard, I disallow this syntax because this doesn't tell us whether set price through the exception of max profit did. Going back to the previous code, this clearly tells us max profit blew up, which is what we are expecting this test to prove and assert. On the other hand, this test may pass for the wrong reasons. A better solution would be what things like JUnit 5 does, where you put an assert throw and specify what exception you are actually expecting from it. And then, of course, as a result, you can be very concise instead of being terse about it. So don't confuse terseness with conciseness and simplicity. We want the code to be simple. We want the code to be concise and clear and transparent, not terse at any time. So I talked about code is not necessarily not clever, code is not necessarily familiar, not over-engineered, not terse. So I've given you a lot of things about what is not simple, but we need to deal with problems every single day. One of my favorite quotes is by Tony Hoare. He says, there are two ways of constructing a software design. One is to make it so simple that there are obviously no deficiencies, and the other is to make it so complicated there are no obvious deficiencies. So we talked about simplicity or the lack thereof, but I can't leave you without talking about what simple really is. So let's try to see maybe what simple is. I can avoid the things we talked about, not making things clever, not over-engineering things, not falling for the familiarity and the comfort zone. And we can look at a few of these things and not making things terse, but instead of not, what are the things we can actually focus on? So let's talk about maybe what is really simple. Well, the first is simple keeps your focus. one of the things that we suffer with the most today is really attention span focus. We sit down to do something. We don't understand how to do things. What do? We search for things today. And that can be a good thing that we can quickly look for solutions, but it's important not to lose focus in the process as well. If you're looking at an API, if the method says in P1, in P2, in P3, you're confused. What do these three ints mean? Why me? Why do these people give me P1, P2, and P3? And now I have to look at a documentation. Well, if you can keep us focused in getting our work done, that would be an enormous blessing. Let's talk about an example here. Let's say you and I are sitting down and pairing up and programming. We're not quite sure what method in Java 8 we should use to concatenate all of these strings together. So you immediately suggest, why don't you search for this so we can get our work done? Hey, searching is a really good thing. We should really do this. Let's give it a try. So let's go ahead and give it a try to search for it. So I'll bring up the search page right here and look for a search. So in this case, of course, notice, oh, look, I brought up Yahoo search. Oh, look at that. Question swirls around $300 million Puerto Rico contract. Well, you know what? It's really been a hard time. And really, we need to really find ways to help people. What else is going on here? Oh, there is news again from the White House. It's really a fun time to watch these things, isn't it? And hey, look at these, all these other interesting news items. Notice what just happened. We totally got derailed from the Java API we were interested in, and we are being distracted about all these different news items, not quite where we wanted to be. Well, okay, so what else could we do? Maybe we could try a Bing instead of going over there. Let's go to, oh, that's a lot. Oh, wait a minute. What a beautiful picture. I'm kind of curious what this picture really means. Maybe I should Bing for what this picture is, but I'm really scared. What if another picture shows up and get into a vicious recursive cycle? Let's give it a try again. Maybe I'll just go to Google and search for it. Well, what do we see here? Not a whole lot. Can you just close your eyes for a minute and imagine the day when the developer at Google went to his boss and showed up and said, hey, look, I've created the search page, the UI for it. And the boss says, show it to me. And he shows this. And the boss says, what else you've got? Well, that's it. In fact, I thought I would add, I'm feeling lucky. Well, you should feel lucky. Well, it takes courage, isn't it? Let's be honest about it. How many of us will have the courage to create a page like this and say, I am done? Well, let's not be naive about it. Well, the minute you click this button, or even before you do, there is an enormous amount of complexity behind this. There are a huge number of servers. There are clouds and clouds of servers sitting there to compute our requests. There are things that are gathering data. There's machine learning. There's AI. There is so many complex algorithms. But those complexities are behind that button. You are keeping the focus of the user. Hey, what are you here for? To search for this Java API? Well, then search. If you want something else about other stories, then you search for it. We're not going to distract you from those things. That is one of the most beautiful things that you see here, is that it keeps our focus, and focus is extremely important from our point of view. Well, here's a beautiful code. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And this is so important. When we strive for creating something simple, our question should be, what are the things we could remove? Remove the clutter in code, remove the unnecessary complexities, remove the accidental details, and then what we are left with, when there is nothing left to remove, is the simplicity we can really enjoy. So it is important to keep the focus of the users, whether you are creating an application and the users of the application, or you are creating an API. And making things simple is the respect we show to our users. We are telling that we value you. Why do most of us use Google? Because we value our time. And when we go there, we get our work done by searching and not be distracted by things. So keeping the focus is a respect we show to our users. Simplicity is a way of respect to the users as well. So simplicity eliminates accidental complexity and hides the inherent complexity that evolves in code. Well, I mentioned that simple keeps our focus, but simple also fails less. And when it does fail, it fails gracefully. Well, I'm sure you've seen this question before many, many times. Why is the cover to the manhole a circle in size? And I'm sure you've heard the answers to this as well. It is because this one will not fall into the hole. Well, sure it is. But step back for a minute. Imagine you're a company interested in building these covers and you put a request for proposal. What are the chances various contracting and consulting companies will come to you with a solution of a circle? Very, very few, in fact. So there are two reasons. They say there's always a story behind a story. So there are two reasons why this is actually a simple and better solution. The first one is you're right, it doesn't fall in. But if you ask for a design where things don't fall into the hole, it turns out these shapes also don't fall into the hole. Well, if you take any one of these shapes, you are safe to assume that you will not drop this into that hole of that particular shape. But the good news is that there is one other problem that this one solves compared to these solutions. Imagine you are part of a team of people who come out of this hole, and the last one who to come out looks at this hole and says, dude, how do I roll this over? In what direction? Well, the good news about the circle is it's the same direction, every direction you see. Just roll the damn thing on it and let's go home is really a good solution. It is very simple to use because it fails less, it just fits in. It reminds me of an experience. I had worked through the night and it was not very safe to drive. It was not wise of me to drive, but I did drive, and I was also low on gasoline. So I pulled up to the gas station. I was about to fill up the gas. I was so tired I could barely think and keep my eyes open, but I couldn't fill up the gasoline because every time I tried to insert the nozzle into my car's gas tank, it just wouldn't work. And after a few minutes, I kind of said, pause, think about it. And that's when I realized I had pulled up to a diesel station instead of petrol. And I was so thankful about this design. Had they not prevented this from happening by design, I would have filled up the wrong fuel into my car and I would have wasted my car. And that was not a very fun thing to do given the economic situation I was in at the time. So I was very thankful for this design that prevented me from doing something absolutely stupid. It failed less at that point and it was very safe. It was a safe default. It really gave it to me. So in designing APIs and solutions, we should ask the question, what if the user were to make a mistake? How do we fail less and how do we fail gracefully and prevent catastrophic failures at this point is something for us to really ask the question. So simpler is easier to understand and easier to work with, like the circle thing that you can just roll over and walk away. APIs have to be really intuitive. And that's one of the things I really appreciate. Rather than having to read and understand a documentation, if it can logically ask the question, what does this mean? And if it is intuitive, that's really a good design that I would say we have at our hand. Well, simple is also elegant. Why is this picture the most popular picture in the world, popular painting in the world? And the reason is it is elegant, but it doesn't have anything unnecessary. It's a picture painting of a lady, doesn't have anything unnecessary. There are no ornaments, there's nothing to clutter. This is simplicity. The beauty here is the simplicity and the elegance. So when we create things, what if we can create things that are elegant? Well, it turns out that's not really always easy. I'll talk about an architect's dilemma here. And I was walking through Boston and I came across this beautiful church called the Trinity Church, and I stood really near the church and I refused to move until my family said they're going to call cops if I don't move. So what was it drawn into? I couldn't take my eyes off of the church. But you may say, well, it's like any other church. What's so beautiful about it? Well, actually, I was not staring at this church. I was staring at something a little different. Next to this church is a huge building called the Jan Hancock Building. And when this building was about to be constructed, the city refused to give permission to construct it because constructing a building next to the church would really diminish the beauty of the church. The architect challenged it and said, I'm going to build it right here. And when I'm done, the church is going to look beautiful, more beautiful than it is right now. And that was the beauty of his architecture. Well, so what I was really drawn and I couldn't take my eyes off was not the church, but the reflection of the church on this building next to it. And this camera doesn't do it justice. If you ever go to Boston downtown, I encourage you to take a look at it. And it's just unbelievably beautiful to look at the angle and the reflection of the church in this building. And I would say that's a beautiful, simple design where he did not do a great amount of effort to really build something that will only enhance the beauty of the surrounding. So we can argue that simplicity is elegant as well. But unfortunately, it is not that easy to create things that are simple. In fact, we have to evolve simplicity. When we create something right off the bat, it probably is fairly complex. We have to refactor, we have to work and rework, and we have to make things simple. When we start out as junior programmers and in the beginning of our career, dealing with that kind of complexity is enormously difficult. But the more we practice it, the more time and effort we spend in making things simple, it gets better over time, and we are improving our ability. It's a skill that improves over time to make things really simple. Well, Richard Feynman said, if you cannot explain something to a first-year student, then you haven't understood it. I've seen this as an experience writing books and teaching courses, that things that I have the most difficulty explaining are really the things I haven't really understood really well. Reminds me of a day when I was teaching in class and I went to explain something for an hour and everyone was confused. Everyone was really frustrated. And I said, never mind, I'll come back and try this tomorrow. And I went home and sat down that night and started thinking about it. And that's when I came to this grim realization that I had trouble really expressing this particular idea, not because it was complex, it was because I hadn't really understood it. I thought I had understood it to a certain level, but there were more things in the layers that I hadn't understood it. And I spent the night really trying to work through this example and getting a better understanding. When I went back to the class the next day and explained it, people said, gosh, this is so simple now. Why did you have such a amount of trouble explaining this yesterday? And I said to them, well, the reason is I was trying to explain it when I hadn't really understood it. Now that I have understood it better, it became easier for me to explain it as well. So this happens even when writing books. An idea that you may come up with may actually be complex, and that's really hard to explain. Well, Occam's Razor says if you have two equally likely solutions to a problem, choose the simplest of those two. But arriving at the simplicity is not really easy. We have to evolve towards that simplicity. We often don't strike gold in the first try. So when I was writing the book, Functional Programming in Java, I wanted to really focus on showing how to do a tail call optimization. Java does not have tail call optimization, but what if we can do it? I've seen tail call optimization in other scenarios and settings. One of my favorite books is looking at the book Structure and Interpretation of Computer Programs. And if I wanted to call, let's say, a factorial recursively, this will blow up with a Stack Overflow exception error because this is a recursion that's going to keep going out of control. But in structure and interpretation of computer programs, they talk about a difference between procedures and process. Procedure is the code you write, process is the one that runs, and you can write an iteration, it can run as an iteration, iterative process, iterative procedure, or you can write a recursive procedure, it can run as a recursive process, or where the charm is, you can write a recursive procedure, but through libraries and compiler support, you could run it as an iterative process. Yeah, I've seen this work in other languages. I've seen it work in F#. I've seen it work in Haskell. I've seen it work in Erlang, Scala, Groovy, Clojure. That's one of the benefits of being a polyglot programmer is you see how a same idea works differently in different languages. And when I was writing the book on functional programming in Java, I said to myself, wouldn't it be so nice to show how to do this in Java using lambdas? So I set out and I merely wasted 3 days of my life trying to implement this. And after 10 more hours of refactoring, I came up with this solution where don't worry about a lot of these things, but focus on this area while not call complete, current equals current dot apply. And that's an imperative solution right in the middle of a book that wants to teach you about functional programming in Java. And I spent 10 hours trying to figure out how to remove this mutability. You see, until that page in the book, I kept telling the readers, avoid mutability, and right here I am mutating. After struggling with this for about 10 more hours, I came with what I would consider as a brilliant solution. And my solution was to write this in the book and put a footnote that said, dear reader, do you notice I'm using mutability here? And turning this code to use an immutable solution is left as an exercise to the reader. Well, unfortunately, that would have worked really well 30 years ago. But today we live in the social media. People are going to immediately tweet and say, oh yeah, so how do you really solve this? Do you have a solution for it? And that's not going to go really well. I thought of a second solution, which I thought was also a brilliant solution. And that was, do you notice I'm using mutability? Avoid mutability except in cases where you cannot. And that didn't feel really well also. I finally realized and came to a grim conclusion that my code simply sucks. And I dropped this problem. I said, maybe I shouldn't really talk about this. I don't have a clue. And I walked away. And about 2 or 3 days later, I was on the treadmill. And as I was jogging, my mind slowly went back thinking about the problem. And it suddenly dawned on me, I can think of a tail call optimization as an infinite series problem. Well, I had talked about how streams can be used as an infinite stream in a chapter before this particular chapter I was working on. So the reader is aware of infinite streams. And I realized, oh my gosh, I could actually do this where I could think of this as a function, which in turn will lead to another function, which in turn will lead to another function. And the minute I thought of it, I jumped out of the treadmill, ran across multiple floors of my house, and started coding this away. And in 10 minutes, I had a solution where I said stream.iterate, go ahead and start with the current function, apply the function to get the next function, and then go on until you don't see, until it's complete, and then find the first one that's completed. Because of lazy evaluation, this one can be implemented using a beautiful function pipeline with no imperative style, using functional pipeline with no mutability as well, at least explicit mutability. And this was something that fell in place really nicely, but it was not easy to do this. It took me several days before I could even think of the solution to implement, but that was one of my aha moments. But that brings up the question, we have to really struggle hard, we have to work, we have to repeatedly try in order for us to create things that are actually simple. And as Einstein put it, everything should be made as simple as possible, but not simpler. But one of the challenges we often run into is the code we write really simple? Well, I can recognize my code is complex quite a few times. I work towards creating simple, but then I would pair with the developer, and the developer would tell me, gosh, that's not really simple, it's complex. And they would come up with a much simpler solution than I had thought about. And suddenly it dawns on me, my gosh, I did not think about it. That's really simple. And the beauty is we do that to each other. I might create something simple, complex, and you may point out how simple it is. And the next time around, you may create something complex, and I may point out how simple it is. And a lot of times, as a creator of a solution, we get tangled up in that complexity. And maybe somebody else looking at it, it could be even you looking at it after a few days or a little later, and you don't have that emotional contract, emotional baggage that you carried with it. You come back and look at it, you might be able to see a simpler solution. A case in point, I wrote a fairly complex solution on Friday, and I wanted to, I was working on this a little ahead of time. It was really necessary yesterday then on Friday, but I started reworking on it yesterday, and I was able to rework it, and it was a lot simpler yesterday than it was on Friday. But the question is it still simple? Or maybe I'll look at it today, or maybe you will look at it today and say, hey, why don't you do this? And maybe there's a simpler solution to it. So is the solution we create simple, or can it be simpler? And I'm going to say simplicity is like shorting your scat. The solution we create at a given time maybe is simple and complex at the same time. It's simpler from our point of view, the way we view it, but maybe it is a little bit more complex and could be made simpler. But we can work our way through creating simple, but is it worth this particular effort? And I want to emphasize that making things simple is absolutely a necessity. There are two things that are going on, maybe three things. First is making things simple is not really easy. It requires hard work. But making things simple is also a skill. First, we have to develop a knack for identifying complexity. A good number of developers go by without even knowing something is complex until somebody else points it to them. And the third is the effort we put in to make things simple really makes it easier for us to maintain the software we create in the long run. So it's worth the effort to make things simple is worth every bit of it. So simple makes things easy, but it certainly does not make it easy to make things simple. So it's something that we have to strive really hard, but it's well worth it. As Da Vinci put it, simplicity is the ultimate sophistication, and it is worth striving for that simplicity. And the more we work on making things simple, not only are we able to create things that are easier to maintain, we also improve our skills in making things simple over time as well. So every bit of it is absolutely worth it. Hope you found that useful. Would be delighted to answer any questions or comments before we move forward.
That's awesome. Thank you very much, Venkat. Just as I print something on my printer next to me, so I hope that's not too noisy. Right, let's see questions. We have a question from Carlos in Slack. Asks, so should Carlos try to refactor all his old Java 1.6 code from loops to streams now to make it more simple?
So one of the things I normally tell developers is we have to always keep in mind the economic cost and consequences of what we do. It's easy for us to kind of get overly excited about solutions and things. So there are three rules I normally apply when it comes to refactoring or changing existing code. The rule number one is that code being changed actively on a project? If the code is not being actively changed right now, there's no reason to really waste our time and effort changing that piece of code. Second, are we currently refactoring for other reasons? Are we making an enhancement? Are we fixing a bug? Well, that's a good opportunity to refactor, not otherwise. And the third is, look at the churn rate over time. Have you been touching this piece of code regularly over the past year or so? Well, maybe this code is in active development. I have a free afternoon. It's worth refactoring this, not changing a very long time. Then I would say it's definitely not worth economically to touch it and change it. So we have to really keep economic sense in our mind and not just do things for the sake of doing. Context absolutely matters in what we do.
Okay, awesome. Another question coming in on Slack from INS. Can simplicity be achieved in the first attempt, or is it usually as a result of constant refactoring?
I apologize. Can you repeat the question for me? I'm having an audio issue here.
No worries. Can simplicity be achieved on the first attempt, or is it usually as a result of refactoring?
I have almost never ever created something simple on the first attempt. If I created something on the first attempt, I would say that's called dumb luck. It actually is not even in the second attempt, not in the third attempt. I'll use is feedback loops and criticism. When I show what I have to somebody, there are two things that happen. The first is when I try to explain it to somebody else, I arrive at a simpler solution myself because I'm slowing my mind down to the point where I'm going to explain to somebody else. I'm thinking through it. We are very intelligent people. We are smart, but we are also stupid. We jump over concepts very quickly and then leave out the details in between. When I sit down to explain to you, I have to slow down to bring the context into it. And halfway through, I'm like, gosh, darn it, why am I doing this? I can make this simpler. So this is one of the reasons why I love interaction with other developers. And a lot of times also, even after I explain it to you, you would look at this, Simon, and say, yeah, Venkat, but why are you doing this? Why can't we do it this way? And I'm like, gosh, why didn't I think of that? And so simplicity arises from discussions and reasserting our assumptions and just slowing down. I think we're way too smart. We're too fast, for our own good. But at the same time, it also plays negatively a lot of times to us.
Okay. Let's jump across to the Melbourne jug. Any questions in Melbourne, Con?
I do have a question. So Venkat, thank you for your great talk. I've got a question about simplicity in groups. So if you were the architect of the Boston church and you had to interact with other third parties, how do you think simplicity changes when you have to interact with people who aren't necessarily part of your posse and your tribe?
I think it's a recursive process, or it's an iterative process rather. So we have to compartmentalize things as well. We can definitely influence simplicity in the bounds that we have. If it's politically and management-wise, it's out of bounds, there's not a whole lot we can do. But at the same time, though, one thing we can do to influence this is suggesting solutions. And keep in mind one thing, though, we live in a world where we are not held hostage anymore to a single point of solution. As time goes on, we will gravitate towards what is economically viable for us. So I may provide a very complex solution to you today, but if I'm not receptive to your ideas, the chances are you're going to move away to something else tomorrow when something is much more simpler and economically viable for you. So having that sense is very important for almost anyone in our industry. Is if we fail to adapt, we get replaced. And that is something we need to really keep in mind.
Changing. Cool. Thank you. Is there any other questions? Right in the back.
Yeah, I've got a question. So when I started doing Java 8 streams, I was very excited, and from that day I started writing everything, like whatever I think I write in Java 8. But over a period of time, even though the code is simple, but because we write in Java 8 streams, the simple code becomes like 4 to 5 liner, which is extremely difficult to decipher, like because we have to read left to right and then come like that. So I'm just asking whether, if you are talking about simplicity, the code which you showed regarding appending the comma separated values, you have showed a big code wherein you're using joiners and adding some syntax sugar. Instead of that, if you just in the for loop above, if you just add a if condition saying that if it's the last element, then instead of appending a comma, I use another. I don't append anything. I just print it. So that's just another if condition. But if you see from instead of a 3-4 line continuously reading, if you just have 5 lines which have gaps, doesn't it makes it a bit simpler to read? It's just my question.
I think you were hitting really on the top of familiar versus simple, in my opinion. I was like you when I did not know functional programming. I was very new style, and I felt exactly like you do today. So I couldn't agree with you more. But I feel very different today than when I felt what I felt years ago when I got into functional programming. And that is because I was very apprehensive because I was not familiar with it. And my mind kept telling me, go back to your comfort zone, go back to the if statement. It is simple. Well, that's one of the reasons why I clearly realized what was holding me back was not simplicity versus complexity. What was holding back was familiarity versus unfamiliarity. And is it familiarity that's making it hard, or is it unfamiliarity versus simplicity versus complexity? I bet maybe after working with this for a couple of more years, once you are familiar, you would feel as I do today than I did once upon a time like you do today.
Okay, awesome. I think we've only got a couple of minutes left before the next session, so we're going to wrap up there. I'll say a massive thank you to Venkat for not just providing us with another amazing session,
Thanks for having me.
but also for kicking off the vJUG24. So a big thank you to
Thank you.
To Venkat.
Thank you, guys.